Chapter 3, Section 1, Getting Started with Propel SDK. In this section of the video series, we will be discussing the basics of Propel SDK, such as workspace selection and project creation. So with that, let's get started with this section of the video series by first reviewing the key points for this video. The first key point for this section of the video series is for users to understand the overall Propel project development flow, beginning from Propel SDK. The second key point is to introduce the basics for selecting a workspace and how your selections impact the following steps in the project development process after that. Aside from that, the next two key points involve the process for creating your own C/C++ projects, as well as how you can import an existing C project into your current workspace. Finally, the last key point for this section is to review the project directory structure and contents for Propel SDK C projects. So with that said, let's quickly review the project development flow, beginning from Propel SDK. As mentioned in Chapter 2, Section 1 of the video series, the exact Propel project development flow that you follow depends on whether you begin from Propel Builder or Propel SDK. In this section, we will review the flow beginning from Propel SDK, so the first step in this flow will be to launch Propel SDK. Once Propel SDK is open, the next steps are to create an SOC project and launch Propel Builder, and then develop that SOC project to generate the required sys_env.xml and driver files that are used to create C projects. Once you've generated those files, the next step is to return to Propel SDK and create a C project which you will then need to develop in order to generate some firmware. After that, the next few steps are to export your project to Diamond or Radiant in order to run through the project implementation flow and generate a bitstream. Next, you will need to program your device using that bitstream so that we can return to Propel SDK and use OpenOCD in order to test our firmware on a live device. Finally, once you are satisfied with the state of your project, the last step of this flow would be to update your SoC's system memory with the memory initialization file generated by Propel SDK. Before I proceed on to the next portion of this video, I quickly want to mention that the advantage of beginning the Propel project development flow from Propel SDK is that your SOC project's files will be created in the same software workspace as your C/C++ project. The advantage of this is improved organization, as creating your SOC project directly from Propel Builder means that your SOC project's files will be in a separate directory than your C/C++ project. With that said, let's transition to my desktop view so we can check out the C project development flow in Propel SDK. So depending on the project development flow that you are following for your Propel project, how you launch Propel SDK may vary. For the purpose of this demonstration, we'll be launching Propel SDK from Propel Builder using the Propel SDK icon from the toolbar, as can be seen on the screen. Doing this will launch Propel SDK, beginning with the workspace selection window, as can be seen here. In this window, we will need to select the directory that we want our workspace to be located at. This is the directory that will contain all of the projects that we create and will continue to work on going forward. By default, the location of the workspace directory will be in the workspace directory of the folder that our Propel installation is located at. For now, we will keep our current workspace selection as the default value. Once Propel SDK opens, there are a few different things that we can do. Since we launched Propel SDK from Propel Builder, the project creation window will open automatically, allowing us to easily create a C project for our SOC project. The usefulness of launching Propel SDK this way is that it simplifies the project creation process slightly by automatically populating the system environment XML field, as well as the process selection field, which we would otherwise have to populate manually. The only selection that you will need to make in this page if you launch Propel SDK from Builder is the language of the project you want to generate. By default, this will be set to generate a C project. However, you can use the language dropdown to create a C++ project instead if you would like. In the next page of the project creation window, we will need to define the name for our project using the project name field at the top of this page. Below the project name field, we can see a preview for the location that our software project will be saved to, which confirms that our new project will be saved to the directory that our workspace is located at. Next, we'll need to select the project type that we want to create. Our selection at this point of the project development process will vary greatly from project to project, However, you should ensure that your cross-compiler is RISC-V cross GCC. For this demo, we'll be using the Lattice C/C++ project template, since that comes with the basic Hello World demo file, as well as some other useful drivers and system files. Once we are done with our project selections in this page, we'll once again need to click Next to continue on with the project creation process. In this final page of the project creation window, we will first need to select the release configuration that we want our project to use, which will be either debug or release. Finally, the last few library, compiler, and linker settings can be modified using either of the three respective tabs mentioned before, corresponding to what you want to modify. Once you are satisfied with your selections in this window, click Finish to finish generating your project. From the example on the screen, we can see that our new project was created and added automatically to the Project Explorer tab. With that said, let's quickly review the process for importing existing projects before proceeding on to the final section of this video. In order to import an existing project into the current workspace, select File from the menu bar, and then Import, and then Existing Project in a Workspace from the pop-up window that appears. Doing this will open the Import Projects window, where we will need to locate the project that we want to import. The easiest way to import existing projects is to select the Browse button in order to locate a directory that contains the project or projects that you want to import. For this example, we will import the project from a previous version of Propel Software's workspace by selecting its base directory. As can be seen from the list of projects, we can use the checkbox next to each project's name to determine whether or not we want to import that project to our current workspace. The only exception is with the first project name in the list, as it shares the same name for a project that is already in our current workspace. Once we have selected the projects that we want to import to our workspace, we should click Finish to finish importing them to our current workspace. Doing this will copy those software project files to this workspace, allowing us to access them and continue development from here going forward. Now that we reviewed some of the software-related basics for getting started with Propel SDK, let's transition back to my slide deck so we can quickly review the directory structure for C projects. So, as was mentioned before, the workspace that you select when loading Propel SDK controls the projects that are available for development. In this example graphic, only one C project is listed. However, depending on your workspace selection, there may be multiple other projects that appear in this location. Within the C project directory are a few various files and folders. The debug folder contains several files that are used to initialize our project system memory and test our firmware on device. The contents of this project subdirectory are discussed in more depth in section 3.3 of the video series, Debugging with OpenOCD. The contents of the source directory are very important, as they contain all the source files and drivers that we'll use to develop our project. In the BSP directory are all the drivers for the components in our project, as well as the sysplatform.h file that contains all the parameter and register definitions for our SOC project. Aside from that, there are also a few other files that are located in this directory, like cpu.yaml, the generated linker script file, the system environment XML file that was generated by Propel Builder and describes our SOC project, and lastly, the source files for our SOC project. Finally, the last few files in this project directory are .c project and .project, which are used to indicate that a directory is a Propel SDK software project. That concludes this section of the video training series. To watch the next video in the series, select the video called Section 3.2, Developing Firmware with Propel SDK.